All right, good morning. Hope you had a good weekend. It's good to have you back. I have a couple of announcements. First of all, those of you who turned in the unit circle quiz, for the most part, the work looked good. There were some problems here and there. To me, it looked like either students knew how to do it or they didn't. But a couple things. First of all, for problems 1 through 13 on that unit circle quiz, there's no work to show on that. Basically, you're just looking at the common angles, you're looking at the reference angles in the first quadrant, and you're just writing the answer. Except for tangent. Remember, tangent is defined as y over x. So you would want to possibly show work on that. And you want to simplify. So can't leave radicals in the denominator of the fraction anymore. So something like 1 over radical 3, no good. You're going to have to rationalize. That's why we did it. So no radicals in the denominator. You must simplify all radicals, and you must know the conditions for simplifying radicals. On problems 14 through 20 on that unit circle quiz, you should have at this point shown 3 steps. So what you do is you find the reference angle, which is a positive acute angle in the first quadrant. You evaluate the reference angle, and then you figure out which quadrant the actual angle is in, so you can figure out if the answer is positive or negative. So I was concerned about that because some of you did not show 3 steps for problems 14 through 20, which leads me to believe you used a calculator. Can't use a calculator. You'll know when you're supposed to use a calculator. The exercises will specifically say, when you're in pre-cal, they will say to use a calculator. So otherwise, you must do problems by hand because you have to give exact answers. I did see the master schedule for next year, and I'm not teaching honors pre-cal. It's Mr. Johnston, but that could change. But just to let you know, Mr. Johnston's tests, he has parts of tests with a calculator and parts of tests he will not let you use a calculator. So anyhow, he's more strict about that. So just make sure right now that you do not use a calculator if you are to do problems by hand. So all the common angles, they should be done by hand. Don't use a calculator. I did have trouble grading some of the quizzes. I'm not sure what you guys are doing, but you're making it difficult for me to see things. So some students' work I can see, I can zoom in, I can scroll down. Others of you I have to use Cami, and it takes 5 minutes to grade your paper because I can't. It just makes it, whatever you're doing is making it difficult for me to see it. So I asked one of my students, I said, what exactly are you doing? Because I can zoom in, I can scroll down, I can see your work. It's so easy for me to grade. And this is what the student said. He said, all I do, I take a picture of my assignment before I post it, and I make sure that you can see it, that it's clear. And then on the same doc as the assignment, he posts the work. So he's saying that on the same doc as the assignment, he posts the work. He says sometimes the picture might come out sideways. So all he does is rotate the picture, which I appreciate because it is crazy when I see the picture sideways. It is difficult to grade. Remember that I have a lot of students, so I want to be able to just look at it and grade it quickly. So I hope that you understood what I just said. And when I check work, when I ask to check work, if you just please do that rather than doing 25 different things. It does make it difficult for me to grade when everybody is doing something different. All right. Lesson 17-2, I'm hopefully finishing it today. It'll be due tomorrow at 9 o'clock. All right. So in going through 17.2, last time I spent a lot of time going over evaluating for that quiz, and that like obviously I spent a lot of time on that because you must know how to do that, and you must know how to do that efficiently. I did talk about any point on a circular arc, and the definition for that the ordered pairs were r cosine theta and r sine theta. I did one problem, and you saw when you find a value or an expression for the coordinate on a circle centered at 0, 0, and at an angle theta from the x-axis, where the radius was 6, theta was 124 degrees, and they asked you to find the x coordinate. We tried to find the reference angle, but it didn't help us because the reference angle was 56 degrees, and that's not a common angle. So we were forced to use a calculator. All right, I want to continue from there. So I gave one example on this. Here's the next example. The radius, I'm just going to call it r, is equal to 2. The angle is 150 degrees. And they want us this time to find the y coordinate. Okay, so radius is 2, theta is 150 degrees, and they want us to find the y coordinate. So we do want to find the reference angle. So to find the reference angle, you always want to go to the closest horizontal. So if you think about the unit circle and you think about 150, 90's here and 180's here. 150 is over here somewhere. So the closest horizontal would be 180. So just go to the closest horizontal and you're going to subtract in some way to get a positive acute angle in the first quadrant. So this reference angle ends up being 30 degrees, and we do know about that, and we are not going to use a calculator. And so we know that y is defined with the radius other than 1, r sine of theta. So you just put in 2 for r, we do sine of 30 degrees, and you evaluate it by hand. And I'm going to want to see the work, and Mr. Johnston will want to see the work. So what is the sine of 230? I'm sorry, 30 degrees, you can use your hand. That is 1/2. So 2 times 1/2, that cancels, is 1. So that's your answer. You should not have any decimal answers. There should be no decimals unless you're asked to use a calculator. Now, one thing you can check here is since the angle is in the second quadrant, you know this is negative positive. So you know that this answer is correct because y should be positive. Let's do another one. Can you guys see the boards okay? Yeah, okay. So in this one, the radius is 3. Theta is 2.4 radians. So there's a decimal, which leads me to believe we won't be able to do it by hand. And then we want to find the x coordinate. So once again, we find the reference angle. And we go 2.4, that's 2 radians. So we know that 1 radian looks like that, and 2 is over here somewhere. So anyhow, you go to the closest horizontal, which in this case would be pi, and you subtract off 2.4, well, that's about 0.74. We don't know anything about that. So the reference angles are only helping us out if we know about them. So 30 degrees, pi over 6, 45 degrees, pi over 4, 60 degrees, pi over 3. But we don't know anything about 7/10 of a radian. So that's out. And that tells us we need to use a calculator. So x is equal to r cosine theta. So x is equal to 3 cosine of, what was it, 2.4? And you must use a calculator. Now, remember that if you're working with degrees and you have to use a calculator, make sure you're in degree mode. If you're working in radians and you're using a calculator, make sure in your radian mode you're getting all the wrong answers. So make a note of that somewhere. That I'm telling you what the biggest mistake people do is when they're using the calculator, they have it in the wrong mode. So this turns out to be about negative 2.21. And I did use a calculator for that. I'll work one more. So if you want to find a reference angle, if you can do it by hand, you're supposed to. If you find a reference angle and it's not one we know about, you're going to have to use a calculator. But don't use a calculator on the ones we can do by hand. Okay, here's one with a radius of 4. Theta is 7 pi over 6. And they want us to find the y coordinate. All right, so in this case, we can find a reference angle. And we don't even need to go to the closest horizontal, because remember when you have something like that, we can just cheat and say pi over 6. So if you're confused and you want to go to the closest horizontal, remember 7 pi over 6, 6 pi over 6 is here. So 7 pi over 6, when you divide that into 6 parts, is going to be down here. So the closest horizontal will be pi. Now pay attention to me. I said to go to the closest horizontal and subtract off the angle. Well, that's going to give a negative angle, isn't it? And we don't want that. So what I'm saying here, and I know that this is crazy, but what you do is you set up a problem just to get a positive acute angle. So subtracting it off isn't going to work, but look at it. If I do this, 7 pi over 6 minus pi, isn't that going to work? So it works every time. It doesn't matter if the angle, if you're subtracting the angle or if you're taking the angle and subtracting the horizontal. I'm going to say that again. It doesn't make a difference if you're subtracting the angle or if you're taking the angle minus the horizontal. You're going to get the right answer. Just make sure you get a positive acute angle in the first quadrant. So remember, we knew it's pi over 6. So 7 pi minus 6 pi is pi over 6. So we knew that anyway. You didn't have to do that. I'm just making a point about subtracting. Okay, so now they want us to find the y coordinate. So y is equal to r sine of theta. So 4 sine of pi over 6, you must do this by hand. So what's the sine of pi over 6? Well, it's the y value, right? Which is 1/2. So you can cross cancel, and the answer is 2. And once again, if you check the quadrant of the original angle, it should be, what, negative, negative? So I left a negative off somewhere. Okay. So anyhow, shouldn't this y value be negative? Yes, because of this. Now, remember what happened here. We didn't evaluate the problem, okay? What we did is we evaluated the reference angle. And then from there, we attach the appropriate sign depending on where the angle is. All right, so the way I'm doing it is I'm finding the reference angle, I'm evaluating the reference angle, and then the actual angle is in quadrant 4, which means y has to be negative. All right. Now we're going to go into some applications, and you can expect these to be on the exam. These application problems are they're real life problems, and I want you to be able to do them. This first one is challenging, but the ones after that, I need you to know how to do, not necessarily this first one. So I'm on page 844. It's a Ferris wheel problem. So if you could look at page 844. Trying to get to it. Okay. I'm probably going to need this board, so I'm going to erase it. Okay, so on page 844, I'm going to read the problem here. A Ferris wheel with a diameter of 45 meters and 24 seats spread evenly around the outside of the wheel is stopped in the position shown in the diagram. Using the center of the Ferris wheel as the origin, what are the horizontal and vertical positions of seat 8? And how far above the bottom of the wheel is seat 8? Solve the problem using radians and give your answers to the nearest tenth of a meter. All right, so if you wrote down the information, the Ferris wheel diameter is 45 meters and there's 24 seats outside the wheel. Okay, so the angle between two adjacent, that means right next to each other, between two adjacent seats is 22 pi. Now 2 pi is a full revolution, right? So 2 pi is a full revolution divided by 24. So that's one revolution, and 24 is the seats. Okay, so that means that the angle between two adjacent seats then is pi over 12 when you simplify that. Okay, hopefully everybody's okay now. All right, so let's keep going here. So the number of seats from seat 8 to seat 1 is 8 minus 1, right? Which is 7. I don't think you can see that, so I'll write this over here. So the rotation angle of seat 8, sorry. The rotation angle of seat 8 would be theta equals 7 times pi over 12. So we're using this 7 and this angle between two adjacent seats and multiplying. So this would be 7 pi over 12. All right, now, what we want to do is we want to find the x and y coordinates. And remember, this definition is r cosine theta, r sine theta, an ordered pair. And you just put the information in. So first of all, what is r? Well, wouldn't r be 45 over 2? Yes, because the diameter is 45, right? And so isn't 45 divided by 2 the radius? So this would be 45 divided by 2 cosine of 7 pi over 12. And the y value would be 45 divided by 2 sine of 7 pi over 12. Now, that does not make sense to a human being. And so we would have to put this in the calculator. Okay, so what you're going to do is you are going to put in cosine of 7 pi over 12, hit enter, and then you could have simplified the 45 divided by 2. But cosine of 7 pi over 12 times 45 pi over 2, that's going to be your x coordinate, which is about negative 5.8. And if you put that in the calculator, you're going to get 21.7. So what you figured out is you figured out that this is left 5.8 and up 21.7. So I'm not going to write the answer down, but I'll read it to you. Seat 8 is about 5.8 meters to the left and 21.7 meters above the center of the wheel. The center is 22.5. That's what this is, the radius. The center is 0, 0. That's the radius. The center is 22.5 meters above the bottom of the wheel. So seat 8 is stopped at 44.2 meters above the bottom of the wheel. So just a reminder here, the diameter they said was 45 meters. So the radius is 45 over 2, which is about 22.5 meters. So how did I get the 44.2 meters above the wheel? Sorry, above the bottom of the wheel? That last statement I made? What you do is you take the radius, which is 22.5, and you add the 21.7. I'll say that again. You take the radius, which is 22.5, and you add 21.7, and that's how I got the 44.2 meters. Like I said, you don't have to worry about this problem so much, but I did want you to see how you could use the trigonometry in a real life problem. These other ones you're going to be responsible for, and let me show you them. So we have a lot of circles in real life. The Ferris wheel's just one of them, but if you look everywhere, there's circles everywhere. So if somebody's trying to do something to a circle, you can bet about $1 million that they're using trigonometry of some type. All right, now, let me just talk about this for a second. Maybe I don't need to. I'll wait until I run into it. Okay, let's take a look at page 845. Example B. Make sure you know how to do these problems from here on out. All right, let me read it real quick. An airplane begins to descend. You want to make sure you draw a picture. It will be almost impossible to do this without drawing a picture. And I know Miss Fresco stressed this. Draw a picture, try triangle. You know, draw it. So now you're going to have to. So you have this airplane. Don't hate because you can't draw like me. It says it begins to descend toward a runway. So the runway is over here. So this plane is descending. So he's descending like this. All right. Actually, is he? I'm going to draw it a little bit different. I'm going to draw it different. Do I want to draw it like that? Let me keep reading. An airplane begins to descend toward a runway 1 mile away at an angle of -5 degrees. So that's why I don't want to draw it the way I did, because I want to draw this angle, and this is called an angle of depression. Now, so let me talk about this real quick. If you have an angle of elevation, elevate sounds like an elevator, right? An elevator takes you up. So this would represent an angle of elevation because it's going up. If something's going down, it's called depression. So it's not that it's sad going down, it means that it's going down. All right, so basically, whenever you draw an angle of depression, it has to go from a horizontal. So even though for this airplane, there's not actually something there, like this has the ground, which is the horizontal. This airplane, it's imaginary, but it's horizontal. And depression would be shown like that. So that's an angle of depression. Either one has to go from a horizontal. So an angle of elevation has to go from a horizontal up, and an angle of depression has to go from a horizontal down. So that's what you're seeing me do here, is you're seeing me draw this imaginary horizontal line, and I'm doing an angle of depression. And they said that it was -5 degrees. I still need to draw a triangle. Okay, so that's my angle of depression from a horizontal. And it says, what is the change in elevation after it flies 5,000 feet? So this thing is going to fly 5,000 feet. So what we're going to see here is a triangle that looks like that. So that's how you want to draw it because of the reading. So I'm going to read it again. An airplane begins to descend toward a runway 1 mile away at an angle of -5 degrees to the horizontal. So see how I told you to the horizontal? So it's 5 degrees from a horizontal. What is the change in elevation after it flies 5,000 feet horizontally toward the runway. So we want to know what that value is. So what you do is you look at this and go, you put your pin on the angle. So it's always, SOHCAHTOA is always based on the angle. You put your hand on the angle, what kind of information do you have? You have the angle, and you have adjacent. And you want to find opposite. So what's that sound like? What does adjacent and opposite sound like? It sounds like tangent. So basically, you have three parts. You have an angle, you have a side and a side. If you know two of them, you can find the third one. So for example, if you know the angle and opposite, you can find adjacent. If you know opposite and adjacent, you can find the angle. If you know the angle and adjacent, you can find opposite. Okay, so let's put the values in. So we have degrees. So we have tangent of -5 degrees. We don't have opposite, but we do have adjacent. So you just solve for y using algebra. So you multiply by 5,000. So you get 5,000 tangent of -5 degrees. That's it. Later, you got to make sure you're in degree mode. And tell me what you get. So you're going to put this in first. Tangent of -5. Don't put the little degree sign because the calculator already knows you're in degree mode. So tangent of -5, hit enter, then multiply by 5,000. What do you get? Go ahead, unmute yourself and tell me. I'm going to erase the board. Want to make sure you know how to put this in the calculator. Go ahead, I'm listening.
-437.44.
Yeah. -437 point, and they asked you to round to the nearest tenth, I think. They didn't tell you how to round. Okay, they didn't tell you how to round. Okay, so I'm rounding on mine. Okay. So what does this mean then? It means that the elevation drops by about 437.4 feet if you were going to write it out. So this isn't negative whatever, doesn't mean make sense to people. So in the writing, when you give it the report to the person who's asking for it, you would say the elevation drops. That's what that negative means, by about 437.4 feet. Okay, that was on page 845B. Let's do another one. I'm going to do a few here. Okay, this next one is a really popular problem on page 846. Number 8. All right. How long a shadow does a 40-foot tree? So you're going to draw a picture. Probably should have moved it over. Okay. How long a shadow does a 40-foot tall tree? So we know the tree is 40 feet. Now they're talking about a shadow. So do you see a shadow floating in the air like a ghost? No. Where do you see a shadow? On the ground, right? So that's what we want to know. So it says, how long a shadow does a 40-foot tree cast on the ground? They told you. If the sun is at an angle of 0.5 relative to the horizontal, so there's the sun, there's it casting its shadow, and then it says, if the sun is at an angle of 0.5 relative to the horizontal. Now, this is the horizontal, right? So aren't they talking about this angle? Okay, so now we decide, is this sine, cosine, or tangent? I don't know, what do you have? Put your finger on the angle. When you put your finger on the angle, you have adjacent and opposite. So what's that sound like? Does that sound like sine, cosine, or tangent? If you have, right. So you have tangent of theta is equal opposite over adjacent. And you fill in the blanks. So this would be tangent of 0.5. That's radians now. That's radians. So you have to put your calculator in radian mode. Radian mode. Got to pay attention. All right, this is equal to, put your finger on the angle, opposite would be 40, adjacent is x. So this is different. Over here, the variable is in the numerator. Now the variable is in the denominator. So you can either cross multiply, or I'm going to multiply both sides by x. So if I multiply both sides by x, I get x tangent of 0.5 equals 40, right? And now to solve for x, you divide by tangent of 0.5. So I know that this looks different than what we're used to doing, but this is what we've always done. So that cancels, and we get x is approximately equal to, and you put that in the calculator. What's 40 divided by tangent of 0.5? Go ahead, somebody tell me. They didn't tell you how to round, so round however you want. So what would that be?
$73.219.
Yep. It's about 73.2. So if you were going to make a statement about this, probably you would say that the shadow is about 73.2 feet. So the shadow is about 73.2 feet. Okay. Let's do one more. Trying to figure out where it is. Okay, I don't know where this is, so I'm gonna have to write it out. All right. Finally got some rounding here. The nearest foot. Plane is flown. Okay, I probably put this in my notes because I just needed another example. So. A plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. When it has gained 500 feet, find the distance to the nearest foot the plane has flown. So let's draw a picture. So a plane rises from takeoff and flies at an angle of 10 degrees from the horizontal runway. Okay, now I can either draw the 10 degrees over there because the plane can fly that way or the plane fly that, it doesn't matter. So I'm just going to put the plane over here. And this is going to be my angle of elevation from the runway. So a plane rises from takeoff and flies at an angle of 10 degrees with a horizontal runway. And when it's gained 500 feet. Now, it's not talking about, this isn't gained 500 feet. When they talk about that type of number, they're talking about the height. So if I asked to measure your height, you would stand straight up. So when it says it's gained 500 feet, they're talking about height. Find the distance to the nearest foot the plane has flown. So the question, so that's the right angle, because you have to have a right angle. Are we talking about this, or are we talking about that? Okay, I think they're talking about this distance right here. So I'm just going to call it C. So if you put your finger on the angle, what are they giving you? They're giving you opposite and hypotenuse. So if they're giving you opposite and hypotenuse, what do you want to use? Sine, cosine, or tangent? You want to use sine?
Sine, right?
Yeah. Opposite over hypotenuse. So we have the sine. Uh-oh. So what's going on? Oh, this should be 10 degrees, right? So we have the sine of 10 degrees is equal to, put your finger on the angle, opposite and hypotenuse would be 500. And I'm calling the hypotenuse C. So I'll show the work this time. You can either set up a proportion and put that over 1, or you can just multiply both sides by C. So C sine of 10 degrees equals 500 divide by sine of 10 degrees. So C is approximately, and you got to make sure your calculator's in degree mode. So now we're in degree mode again. So what do you get? You have to round to the nearest foot. Is that what you got? So you would say the plane has flown a distance of 2,879 feet. Okay, now I do not have this in my notes, but I do want to show you something. So I'm going to try to make up my own problem here. Okay, so let's say you had a building. And your picture looked like this. This would be your right angle, right? And let's say that they told you that there was some type of wire or something that was 100 feet away from the building, and the length of the wire, for whatever reason, let's say they're hanging something on it. Let's say the length of the wire is, I don't know, 32 feet. It's gotta be longer, I'm sorry. 132 feet. So they tell you all this, but they want to know the angle now. So all the problems that I worked, I gave you the angle. But now we want to find this angle. Like, what is the angle of elevation here? So if you put your finger on the angle, what do you have? You have adjacent and hypotenuse, right? So what does that sound like? So, ca, or toa? Sine, cosine, or tangent? You have adjacent and hypotenuse. Is it sine, cosine, or tangent?
Cosine.
Right. Now, this is a little bit different. Watch what happens. You have cosine of the angle is equal to 100 over 132. This can be reduced, right? By, I don't know, 4 times with what, 2 remaining? 4 times what? 5. 4 times what is 13? 3, with 1 remaining is 3. Is that right? So now watch this. And we want this in degrees. It's a real life problem. To find the angle, you have to use the inverse key. So these are not reciprocal keys up here. These are inverse keys. So you have to use second cosine to get cosine inverse. So that's an important thing to know, is if you're trying to find an angle, you have to use the inverse key. And I don't care what it is, sine, cosine, tangent. If you're trying to find an angle, you have to use the inverse key. Okay, so somebody use the inverse key and tell me what you get here. I don't know what the answer is. I just made this up out of my head. I'll do it, but somebody give me the answer. It'd be cosine inverse of what? What do you get? I don't sing.
$40.75.
That's probably right, and I'm probably in the wrong mode because I didn't get that. So I'm gonna check my mode like I told you guys to do. Sure enough, I'm in radian mode. Gotta be in degree mode. Try it again. Cosine inverse of 25 divided by 33. Okay, what'd you get, Marnona?
40.75.
Yeah. So 40.75. And depending on how they want you to round, you could say, oh, it's about 41 degrees. So that's how you find an angle. Now, I don't know if you have to do that, but you will have to do that at some point. So it's just good to know that you try to find an angle, use the inverse key. All right, that is the lesson. It is due tomorrow night. I am going to turn off the recorder. But for some of you who are confused about evaluating the unit circle quiz, we can hang out because it'll take me 2 minutes to clear up your problem, those of you who are having issues. So I do recommend you hang out with me and because you can't make, you know how important signs of numbers are, positive and negative? You know, remember when you first started with me, a lot of you thought a negative and a negative was a positive, and it's not. A negative and a negative is a negative. A negative times a negative is a positive. Okay, this is as important as that in trigonometry. So you cannot mess up on evaluating reference angles and associated angles of the common angles. You cannot mess up on it at all. You can't make mistakes on negatives and positives and the quadrants or anything. So if you want to hang out with me, I do recommend you do that. But for the rest of you, have a good day. Don't forget about the assignment. Pay attention because I'm going to have an exam coming up pretty soon. But here's the deal. I know that there's a lot of AP testing. I do not want to burden you with an exam with the AP testing. So you got to let me know. Make some recommendations like, oh, this day's good for the test, or this day's good, or this day's bad. I don't want to stress you out during AP testing. Okay, this test is not as important as that. So, but you have to communicate with me because I don't have the AP schedule. I don't know what's going on. I'm not an AP teacher. So I just don't want to burden you with the exam. So give me some feedback. Okay. All right. Have a good day. Those of you who are taking AP tests today or tomorrow, hey, good luck. Just do the best you can. Don't stress yourself out. All you do is you just do the very best you can. And then you just have to let it go. Okay, you do the best you can. That's all you can ask for, is just doing the best you can. All right. Okay, good luck.
I'm gonna turn this off. If you want to hang out with me, we can do that.